method, that is the k-means clustering. The problem is that we are given a dataset which consists of n samples. So we have x1, x2 up to xn. Yeah, so each x, that is we have a d-dimensional space. So that means when you zoom into this x, we will have different elements. For example, x11 up to x1d, for example. Yeah. Okay. And now we would like to divide this dataset into C clusters or C classes. Yeah. So that means in the terminology, that is K equals C. So when we say K means clustering, this K, that is the number of clusters we would like to have. Yeah. So now we have to specify what value of C it is. So the problem is reduced to this goal. We would like to find C mean vectors M1, M2 up to MC, so that this is the clustering centers. We will use these clustering centers to determine which class each sample belongs to. Yeah. So in order to implement this algorithm, we use this criterion. That is, we try to minimize the distance between x with respect to those centers. So that means the closer the x, the sample x to the cluster center, and then that cluster center, that is this sample belongs to. Yeah. So we use the Euclidean distance as the matrix to measure the distance between samples and the center. Yeah. Okay. And now once we come up with this clustering centers, we are going to use these cluster centers to perform classification. Later on, I'm going to give an example to illustrate how to do that. This algorithm, that is an iterative process. So the pseudocode is illustrated right there. That means we are going to repeat this process until the clustering center, they don't change much. Yeah. So when I say much, that is very vague. We need to have a criterion to tell when to stop. For example, the clustering centers does not change for several iterations, and then we stop. Yeah. Okay. In this slide, I'm not going to explain the details. Instead, I'm going to use the example right here to explain line by line the pseudocode. Now, this example, we are given a dataset S. Okay, we are given a dataset S, and then so now we are going to choose M1 and M2 because we choose, when we apply this k-means algorithm, we would like to divide this dataset into two classes. So I just choose K, that is 2, or C, that is 2. Actually, we can choose any number. For example, K equals 3, it means that we are going to divide these samples into 3 groups. Yeah. Anyway, as the dataset, we have x1, that is this data point, x2, that is this data point. So we have x, we have the first element x1, the second element x2. We can extend this idea into hyperdimensional space. So now why I choose M1 to be x1, M2 to be x6, that is, I just randomly initialize the cluster centers M1 and M2. You can choose any number. Okay, and now with these settings, I'm going to explain this algorithm. Now I initialize, and that is, I know that we have 6 samples in the dataset. Yeah, so this depends on the application. And now I choose the value of C, that is 2. It means that I'm going to divide this dataset into 2 classes or 2 clusters. And now I have M1 and M2 ready. I just choose one of the samples to be class 1, to be M1, another samples to be class 2. Again, you can choose different value. Yeah. And now we enter this line that is classify the samples according to the nearest MJ. So that is the meaning right here. So corresponding to each sample, this is x1, I'm going to compute x1 minus m1 when I equals 1, and then find the distance. I list right here because x1, that is m1, so the distance is 0. So we are going to do that for every samples from x1 to x6 using this equation to compute the distance. The same applies to m2. So if we have more centers, we are going to do m3, m4, and so on. And now classify samples according to the nearest mj. It means that we are going to pick the distance which is smaller compared with these two. So this is shorter. So it means that the cluster, it means that x1 is closer to m1. So we are going to assign that x1 belongs to cluster 1. Graphically, you can just find out that this is the position of x1. This is m1 given right here. So the distance is 0 because they overlap. And then we move on to x2. We find the distance between x2 and x1. So this is the distance. And then we find the distance from m2 to x m2 x2 and m2. Yeah, so that is this distance. Yeah, so this x2 to m1, x2 to m2. So from the table, we just find out that this is the shorter distance. So we claim that x2 belongs to class 2. Repeat this process. We come up with the assigned cluster for each sample. Yeah. So now we are going to recompute mj. So we compute mj, that is according to this equation, that is according to the assigned centers. We have x1 and x3 belongs to cluster 1. So the new center, that is the x1 plus x2, find the average, that is the new center for m1. And then now x2, x4, x5, x6. Yeah, so this is x2, x3, x4, x5, x6 divided by 4, the average of all these samples. And then this is the new center for m2. So after the update, we just find out that we update the centers, and then we are going to check whether there would be any change in m. Yeah, because m1 changed from 1 minus 1 3, m2 that is changed from 3 2. So that means this is still not stable. Yeah. Now, if we do not stop and then we go back to the top, using the new centers m1, m2 to compute the distance. Now this is the new centers m1 and m2. When you look at these figures, now this is the new center m1, this is the new center m2, and we are going to compute the distance between x1 and m1, x1 and m2. So we come up with these two columns. Yeah, according to this line, we are going to determine which class or which cluster xi belongs to. When we talk about x1 minus 1 3, and then the shortest distance, that is 1.11. So we classify that x1 belongs to cluster 1. And then the same for the west. Say for this one, this is smaller, the distance between x4 and m2, that is smaller than the distance between x4 and m1. So we are going to classify that x4 belongs to cluster 2. Yeah, so we come up with these assignment, and then based on this result, we are going to recompute mj. m1 coming from x1, x2, x3 right here. So take the average. The new center, it becomes 0, 2, and then M2, the second cluster, that is contributed by X4, X5, X6, that is right here. The new center, that is 4, 2. Yeah. So we are going to check whether there would be any change in MJ. So 0, 2 is different from this number, and then 4, 2 is different from the previous M2. So there is still change. We do not stop and then go back to the top. We enter the third iteration. Repeat this process. We just find out that M1 and M2 does not change. These two M1, M2, they are exactly the same as we obtained in the second iteration. So it means that we are not going to, we are going to stop and then return M1, M2 to be the cluster centers by the algorithm. And now, when we have a new samples, for example, X7 right here, and then to which class it belongs to, we do the same thing, that is measure the distance. We are going to have a point right here, measure the distance. This is X7 minus M1. And then we measure the distance, X7 minus M2. Pick the one which give you the smaller distance, and then that is the one it belongs to. That is the cluster it belongs to. For example, this one gives you 6, this one gives you 8, and then so we are going to say that X7 belongs to cluster 2. Yeah, belongs to cluster 2. Okay, what happened if they happen to be the same? In that case, we have to apply some policy. Yeah, so maybe we are going to randomly assign X7 to be one of these two classes. Okay, and now when we talk about k-mean clustering, and then so the algorithm, that is to minimize the sum of errors. The sum of errors, that is right here. So we are going to minimize the sum of the errors. I mean, when I talk about the error, that is the error distance, yeah, xi minus m. Now, I'm going to point out some issues about the k-mean clustering. So when we have this data set, two groups right here, but now, for example, this is the M1, this is the M2. So C, that is 2 in this case. Now take a look at this. It just means that when X belongs to the cluster 1, D1, and then we are going to find out the distance, that is this bit. Sum up all the distance from each samples to the center, and then we can find out the total distance for the first cluster. And then when J become 2, that is this one, we do the same, find out all the distance. Yeah, and then sum it up. That would be JE, k-mean clustering algorithm. That is just to minimize this distance. We can just find out that in this case, JE is large, and then in this second case, if we are going to construct a cluster in this way, JE is smaller. So, but when we look at the data set, it makes more sense to us that we are going to have this boundary rather than this one, because there's a gap right here. Obviously, this should be one group, this should be another group. But when we choose this kind of Euclidean distance as the metric, and then it gives us this result. Yeah. So sometimes the result doesn't make sense, but we have to choose the metric in order to make sense of the cluster. Yeah. And also, we've just found out that the k-mean clustering works fine when the cluster form well separate, when the cluster dataset they separate far away from each other. And then so say we have data points right here, we have data points right here, so we can just simply have two groups. Yeah. So if they are going to be very close to each other, and then this situation will happen. Yeah. Okay, but why we still use the k-mean clustering? Because k-mean clustering, that is very fast and very simple to implement, and also it works fine when the data is well separated, and also in each cluster they are in a compact domain. Yeah. Okay, but the thing is that this clustering method, that is very sensitive to the initial location of the centers. That means if you are going to choose different value of M1 and M2, they may not converge. This algorithm may not converge. Yeah. Okay. So in the literature, we will have different variations of k-mean clustering, and then with the use of different kind of metric to implement the k-mean clustering method, and then also k-mean clustering also refer to c-mean clustering. They refer to the same algorithm.